Okay,
Yeah,
new episode.
yeah. We're gonna talk
So,
about more controversial topics, I think.
well, I don't know if it's really controversial, but nevertheless, it's an interesting topic. Like new
Yeah, it's not really
terms,
controversial, but a lot of people,
buzzwords.
if you ask define buzzwords,
Yeah.
then it's
And
very
this comes
difficult.
out.
Everyone will give you a different answer. That's
Oh,
kind of it.
and another thing, very important, we reached a milestone, I think. Like if you do more than 7 episodes of a podcast, I think
Ah,
this will
yeah,
be 8. What was the percentage?
70 between 70 and
70.
80% doesn't make more than 7 episodes in a podcast. I think that was a metric.
See,
So yeah,
that's already a huge milestone, I think.
yeah, we are in the 20 to
Confetti,
30%
poof,
now.
like
Yeah,
confetti cannon and stuff like that. So, yeah.
yeah,
Awesome. Too many more. So,
yeah.
yeah, I would just jump into it, right? Like, um, DevOps engineering, platform engineering.
Cloud
There are
engineering.
cloud engineering. All like have like
Loaded
intersecting
words.
circles, but it are loading words, and like in every organization, it means something different, right?
Yes, I think every organization defines it different as well. We might even define it different. And when I was
Yeah,
looking on Reddit, everyone defines it different. Um,
exactly. When I
but I
first
think
was
that
reading
yeah, go
about the definition, it was like, don't we already do that? And then,
ahead.
yeah, actually, we also do platform engineering, but we understood it more like in the past as DevOps engineering, but like not really DevOps per se, but it was like, yeah, in the end, we already were working on it depending on the client, right? Like not the needs are not the same for every client. So in that sense, it makes it interesting that yeah, that there's some new terminology to define and clearly scope it, I guess.
Yeah, well, I think it makes actually sense to have a word like that, to have a title like that,
Yeah.
because if you look into it, there is actually a difference. So if you look at how we started doing being a DevOps engineer, and even then that word is like a bad word to define what you are doing.
Hmm.
Um, because DevOps indeed is like a culture. This is how it all came
Yes.
into place, right? But indeed, as a DevOps engineer, you're doing pieces to enhance a culture where you work together with developers. So what are you doing then? Okay, you're building pipelines. That's what we started doing.
Hmm.
Remember back in the day with Jenkins pipelines, the
Yeah.
Jenkins file. Um,
But it was already
like
advanced Jenkins. That was
yeah,
Jenkins.
advanced Jenkins. So I think, um, in the first stages, what you're doing, you're writing these build files, you're making the pipelines, you're making sure that the code that your developer is writing, that he can easily deploy that somewhere. It doesn't even need to be cloud. You know,
Yeah, no.
you have the Jenkins file, it has build application, test application, deploy application. And deployed application could be a plugin or like an SSH command that deploys it somewhere if you're not
Yeah.
on
Capistrano.
AWS or the cloud. Capistrano, yeah. Ansible, Capistrano,
Yeah,
all these tools. Um, and that's how we started as well.
yeah, definitely.
Maybe your Jenkins was running on EC2. You would deploy on another EC2 with an auto-scaling group, or maybe you would use Packer or something like that, Packer to build your image. This was like pre-containers kind of like
Yeah.
when Docker was already there, but they didn't even have networking. So it was
Yeah.
not really very usable yet. Um, and and I think in when you are doing this, designing the pipelines, designing the build, you're not really a programmer, and it's also not expected of you to be a programmer.
Yep.
You're more like the person that works with all these tools that are available, but you're not really going to extend the tools. You're not going to write Java plugins, maybe, but maybe not.
Not
Maybe you're
true.
going to write Java plugins for Jenkins, but it's not a full tool. You're not really a software engineer. Um, And I think that kind of changed like in the later years where maybe more bigger companies start to say we actually want some more internal tooling that just us use with the way we see how DevOps should be implemented. And I actually think that
Makes sense.
Netflix is a great example from that for that. Remember all this tooling that Netflix came up with, like Spinnaker,
Oh yeah.
and then they had their own load balancer. And then that was around the same time, I think around 2014, 2015, they were getting more popular. People were
Yeah.
also adopting Spinnaker. And that's kind of when Netflix engineers were developing this system, I think they were really platform engineers. They were
Yeah.
creating a custom developer platform for developers, the tools for developers to be able to build and deploy the application. So
Yeah.
you're kind of creating a self-service, platform engineers are creating a self-service for the developers um, to for them to be able to register the services and deploy the services that they need, or maybe even databases. So in a way, AWS, even cloud, is also a platform.
Hmm.
Um, but using AWS or cloud doesn't make you a platform engineer. I think making a platform engineer is really that you write your own custom self-service. And then when I was reading about why does it make sense to write your own platform, I found a really interesting answer. It is to reduce cognitive scope, I read somewhere.
Hmm.
And that really resonated with me because just imagine how much time and effort it takes to learn how a platform works. Let's say you don't know anything about AWS, or you don't know anything about Azure, or don't know anything about uh, Google Cloud. Like how much time it takes you now to get up to date with all these technologies,
Yeah.
all these products that AWS offers, all these products that Azure offers, that which are completely different than the products that AWS offers. So it takes so much time. But you just want to get your application out. So for a developer, does he need to learn how this platform works, even though it's even like developer focused uh, products that he would use? It's still a lot of effort. So if you are in an organization and you can say, okay, we have this platform team, and they're gonna make it very easy for our developers to build, deploy some of the services they want to run or the new services they want to run, um, reducing this feedback loop, reducing the training that they need because you build something custom. Um, that's really positive. I think that's really a positive thing to create this within the company, to have something. I think for Netflix it was Spinnaker, uh,
Yeah.
and within the organization you can have your own documentation. You can have people that help you out, and it might be much easier to just learn this one tool that you wrote internally than to learn how to use AWS. And that one tool can also incorporate all the aspects that you want to have. Let's say that this one tool deploys in AWS. On AWS, you would have to go and say, okay, but I want to have this secure. I want to have
Yeah.
wire encryption, at rest encryption. I want to have this TLS certificates. I want to have that. And this platform that you internally built could actually by default incorporate all these things. So it
That makes
reduces
sense.
cognitive scope. You don't have to learn about all these details
Yeah.
that you would otherwise have to learn about. And it can make it much easier within your organization to do that.
Yeah. Totally makes sense because like the cloud providers, they can become like seriously overwhelming. Like yeah, it's a really good like quote actually, because if you look at AWS since the start, when you had like S3, EC2, some networking, not even a VPC, didn't have to worry about that. But like, um, yeah, it was just so easy. But nowadays, just keeping up with all the services is already quite challenging to choosing the right. So if you have a team that like moves that even to the background. It can still use it in the background, maybe, but whatever, and just abstracts that from the developer and just like you said, yeah, that really reduces your cognitive load, in order to be able to achieve your goal. Because I think it's easy to get lost in all those toolings, and yeah, that doesn't bring any business value anymore, right? Like if you're looking hours and hours on how many ways are there now on running containers on
Oh yeah, there was
AWS,
like
for example.
20
Exactly.
different ways or something like that.
So
Which one
instead
should you
of
pick?
just running the
Indeed.
container on XYZ technology, you're just looking at, should I do it this way or should I? So I can completely understand that. Yeah. And I didn't hear the quote, so it resonates at this point in time, real time with me. So that totally makes sense. Um,
There's also then a lot of companies that we saw that adopt the platforms of other companies, like Spinnaker. And then
yeah.
it doesn't turn out very well, I find. I've seen it not turning out very well because
Yeah.
it's not really a platform that has been written for their organization. And Netflix is so much bigger. And they use also specific tooling, like these load balancers they use, things that plug into to Java Spring.
Yeah. Yeah.
So you're all missing these other components, and then it doesn't really fit in their organization. So even though you have these different platforms that platform engineers made in different organizations, these might not be a good fit within your organization.
Mhm.
So, um, like adopting a platform might not be the right way, but even then, you might not have the skills, the money, the time to deploy your own platform, and then it's often even just better to keep using AWS and just be this kind of DevOps slash cloud engineer, where I find have this one person or a group of people that deploy everything on AWS, that learn everything about AWS, and then just make the exposure to AWS to the developer a minimum. The
Yeah.
developer needs to know that he needs to use S3, he needs to use the AWS SDK in his programming language, maybe DynamoDB. So he's definitely exposed to AWS, but maybe not to
The,
the
the
products that are,
public access and stuff like that, like
yeah,
the
like
nitty gritty
security
details.
groups.
Yeah.
Yeah, then they don't need to really be exposed to that.
No.
That's kind of that team. Um, otherwise it takes them a lot of effort to do infrastructure work while they should be really delivering features.
Yeah.
And then so I don't think platform engineering is the next step. I think there is also a lot of value in just having a team that a cloud engineering team that does these DevOps tasks
Yeah.
for the developers, and still have a very successful way of delivering their software to the cloud.
Yeah. Absolutely. Because like how I interpreted it right now, if you look at platform engineering, that it's almost a synonym with the really big companies, basically. Like like the scale of it before, like I think like the majority will still it's hard to put it into categories, but like it will be still a mixture between DevOps and platform engineering in smaller companies than the clearly defined platform engineering role. I think that's solely yeah for quite scalable
Maybe
organizations already.
maybe for SaaS companies, it's gonna be overkill if you just have
Yeah.
one kind of product that you deliver. But if you look at the companies we work with, it starts with the SaaS platform. But then, oh, I need to deploy it on this other cloud, and I need
Yep.
to deploy it over there and on-prem. So maybe when you have multiple deployments, platform engineering could become interesting in a way that you're abstracting things away, like your cloud provider. Building your own platform can actually help you to go multi-cloud. Because I don't think there is a lot of interesting tooling available on the cloud providers itself to build a multi-cloud setup. But if
So
you
the
kind of build your
utopia.
own, yeah, exactly. Because there's still a lot of, like, even when was it? Last week. Last week someone told me, so when I'm using Terraform, I thought it was cloud agnostic.
Yeah.
But then you have all these ALS prefixes, so it's not cloud agnostic. It's like, exactly,
No,
not cloud
exactly.
agnostic. So
Yeah.
before using this tooling, this infrastructure as code tooling, in their head, a lot of people still think that this is cloud agnostic. So once I can write once and deploy it on multiple cloud providers, which is not the case.
Nope.
And then they say, okay, then I will use Kubernetes, but then these are also not completely cloud agnostic. So I think that building your own platform could be on Kubernetes, which is a very popular decision right now, I think, or just
Hmm.
on a cloud provider. You use ECS on this cloud provider, but you abstract this away, and then you use some other container technologies on other cloud providers, or whatever is available. So going to a platform to abstract these things can actually help you, I think, to build your own platform agnostic from these cloud providers, or more agnostic, because it's never going to be completely independent from each other. Like even in the application, you would still have to have support for S3 and other object storage, like the other cloud providers have their own object storage, so you'd have to make it compatible, just like we did with some of our tooling. When it can run on multiple cloud providers, you have to kind of support every product within the application as well. Um,
Yeah, for sure.
and I don't think Kubernetes solves that. Like Kubernetes is just compute, mainly compute. It's not object storage. I mean, you can bring in object storage on Kubernetes, but that's not what people do. People will still use the native products from a cloud provider. So you would still have to kind of build that in. But I think when you really start talking about, okay, we need to use multiple clouds, we need to deploy on the customer side, then I think platform engineering can also definitely help you achieving your goals. And also now, if you think about all this generative AI and the money it costs to get the GPUs and the difference in GPU pricing over the different infrastructure providers, this might actually be something that a lot of people need to look into building a platform to run inferencing, to run training at
Oh
the
yeah.
the, the least expensive infrastructure provider, because now this takes such a proportion. The cost is so big of having these GPUs that it actually might be worth the effort to make a platform.
Oh yeah, definitely, definitely. Especially like yeah, it's also especially because it's now such a hot topic. A lot of providers are trying to reel in new clients and keep them, and yeah, they have to also pay off their infrastructure and stuff like that. So it's would totally make sense to make it like portable. It's maybe a wrong word, but like the cloud agnostic turn, I've heard it so many times and miss. Yeah, like it's been. Sometimes it's just like, okay, what are you doing? So you run containers, you use S3, and you use MySQL, just something like that. Like, and then people try to build like a complete architecture around it and spend weeks, months, years on an architecture that can actually do that without having to be cloud agnostic. While how much time would it take to rewrite your app, for example, to use the XYZ cloud alternative for the technology you're using? Because they're all kind of like, you have queues, you have databases, you have whatever, you even have compatible technology like Redis, MySQL database, whatever. So sometimes it's like it's just a lot of effort going into that in my opinion is like completely wasted, that never is going to be used either way. Like but yeah, that's maybe a different story.
I think it's kind of the same story. It's like, at what point in time are you going to do platform engineering?
Yeah, yeah, yeah.
And you're not going to do it when you just have an application and you can run it on one cloud provider. There's no reason to be cloud agnostic if you're just going to run on one cloud provider.
No, absolutely
So
not.
in the beginning, MVP phase, just like the first year or years, when you don't have to run on multiple cloud providers or on
Hmm.
an on-prem system, there's no point in doing this.
Yeah,
Um, but then at some point, now everything is deployed in containers. Um, at some point, I think um, when you need to bring these containers to a customer that is on-prem, that is a big enterprise, and they don't want to use a cloud provider because they're a bank, or they just don't want it. Um, then often people end up in Kubernetes,
yep,
because
absolutely.
that's kind of the cloud agnostic like infrastructure agnostic way of providing compute. And the interesting thing there is that you have ways built in to write code to start making your platform. Now I'm talking about like these Kubernetes operators, so that you can actually run your tooling within Kubernetes, have the configuration stored in the same way as you would store your other configuration, like your pod configuration, but you can then have your custom resources that has some custom attributes that you define as an organization, and then have your software kind of listening to those changes, and whenever you make changes or add new resources, and then do certain actions.
Yeah.
So there's a very interesting way of building your own platform using Kubernetes as well, I find.
Yeah, definitely, definitely. Totally makes sense. Um, because like, yeah, like you said, larger organizations, they're not just gonna say like, hey, we want to run it on-prem. Um, Here's the pizza box, do your thing. Like they already have some set of defined rules and stuff like that. So it totally makes sense to do it that way. And yeah, also, I've kind of lost my train of thought here, but I think it's interesting that like that they made a distinction between those two terms. But like I said in beginning as well, like I think in smaller organizations will still be like a mixture between the two, like DevOps slash platform, and even DevOps is then wrongly used if you use clearly look at the like the text, because like a DevOps engineer can't exist. It's a cultural thing and stuff like that. You know what I mean? Now we're getting into the controversial thing, I guess, but like in the end, so like people like to do their job, and like developers like to develop, and yeah, obviously it's like breaking down silos and stuff, which happens, but I think like um, dividing the responsibility of the DevOps engineering role between the development teams, you need to be really good aligned in the beginning to be able to not have like an explosion of cloud providers and mixture of technologies and stuff like that to have it streamlined. I don't know what you think about that.
I think having titles actually helps in how you have to hire for these roles,
Yeah.
because a DevOps slash a DevOps engineer, let's say DevOps engineer, right? So you're building um, the pipelines. Maybe there's a very difficult pipelines. Maybe it's difficult to deploy applications. Maybe that's indeed like this is your full-time job.
Hmm.
Um, you maintain maybe Jenkins, maybe a Kubernetes cluster. Couldn't be on-prem, could be on the cloud. Then you have a cloud engineer, and this person maybe doesn't know that much about how you build software, and is more on the I can build all the resources on AWS for you because I am AWS Architect certified. I am AWS SysOps, DevOps, security, networking
Yeah,
certified. So
makes
that
sense.
person knows how to take care of that part. But both of these profiles, they don't really have, or don't they maybe have, but they don't need a software development background. But then once you go into platform engineering, you need to hire someone that knows about how DevOps works, how cloud works, but also knows how to program, how to deliver software. Because all these DevOps techniques, you also have to incorporate within this internal software that you're going to write. It's going to have to follow the software development lifecycle of the company as well. You're gonna need tests. You're gonna have to deploy it as well.
Hmm.
So
Preferably,
I
yes.
think the platform engineer is actually the job role where you need the most of skills, because then you also need to program it. And I think Golang now is very popular uh, because of Kubernetes, because of these operators that you can write. There's probably like most documentation that is available, and Kubernetes and Docker have been written in Go. So and it's also very good for to system programming. So Go is really an interesting way to go. Go is an interesting way to go.
See
uh,
what you did there. Pun intended,
uh,
yeah.
so you need to know quite a lot of things. And then once you go into this platform engineering, you have to write the code and you have to interact with Kubernetes. It immediately gets the complexity immediately goes like much higher because it's not that easy to write software for that. It's not like I'm building a REST API and I will write something to the database and I'm done.
Yeah.
It's like these systems like Kubernetes super complicated. And I was like in the last couple of days I was also looking into something like container D and Docker desktop and how it all fits together.
Oh, with the
And you
licensing.
would Yeah, and also with the licensing, because Docker Desktop actually requires a license for companies that are bigger than just a small company. I don't know what the cutoff is, but there's a cutoff, and then if you're not a small company, you actually have to pay for it. You have to take the subscription,
Yeah.
uh, which maybe not every company wants to do that. Maybe they want to use containers, but not Docker. So then there was indeed this open source movement. So we are not going to use Docker daemon anymore within Kubernetes and other programs. We're going to use Docker D, and Docker D is going to abstract um,
Container
how
D.
you container D,
Yeah.
container daemon, yeah.
Yeah.
And it's going to abstract this is going to be the layer just to kind of the interface to start, stop containers, pull containers. But that's just like one layer. Under it, you still have what they use run C is to run the container. So for example, on macOS, there's not really a runtime because
Yeah.
there's no way to I mean there is a way, but the way of creating a snapshot and volumes and a container is just not there yet. Um, so you have container D run C. And then actually, when you go and look into it, let's say that you say, I wanna use containers, but I don't want to use Kubernetes. So I'm gonna write some really simple program that is going to use container D, and container D is going to launch for me a container somewhere. So I could have like a few of instances somewhere. I'm just going to use container D with some programming language, uh, and then this is going to launch containers. But that's quite interesting because they removed Docker from it.
Yeah.
And then they say, okay, now we have just container D, but container D is not on par with the features of Docker. So what you actually now see is that when you launch a container D is just like starting the container, uh, and then all the networking stuff that we earlier said that almost implemented later is not there. So if you are in Kubernetes does that for you. If you are with Docker, Docker does it for you. But within this open source community, you actually have to take care if you want to implement just container D and your own software to launch containers, you would have to implement your own networking. There's no API for that. And if you would just use Docker, Docker has the API. Docker has like, oh, start container, here's your networking information. So even if you then, let's say you are a platform engineer and you're going to look into these things, you very quickly realize that there's massive gap everywhere. It's not that easy to kind of just implement something.
Yeah.
And then okay, it can be useful to adopt Docker and to use Docker, but you can then see why so many people actually use Kubernetes because you kind of need some kind of base platform, even
Oh
though
yeah.
you have to, even though it's a lot of maintenance, this operator framework actually takes away a lot of things. So that was I was investigating. I was super surprised um, that there were so many gaps, for example, in networking, that kind of that you would have to implement yourself if you would not use Kubernetes or Docker. I thought like, oh, we pushed containerd so much in the last years. That must be like a great piece of software because now we have open containers and now we take care of all these things. But actually, when you go and look into it, it's like a heck of scripts and hooks and whatever to get everything working. And actually, even today, I think Docker is still like a great piece of technology, because if you see all the features that they still have, okay, you have to pay for it. Um,
Yeah, true.
but as a platform, it's also quite interesting. So if you look at platforms, so you have Kubernetes did a big effort to be completely open source and everything. So Docker is kind of out of there. Then you have Docker. Docker has Swarm, not very popular, but I still saw
Yeah.
some people using it. Docker can kind of help you to easily deploy containers if Kubernetes is like completely overkill. And then you have HashiCorp. Uh, and there's also a lot of things happening with HashiCorp, like they're changing the licenses, and I'm sure we should have another episode
Oh
on
yeah.
just the licensing, because what's happening
Yeah.
there. But HashiCorp also has their own ecosystem uh, of container tooling that you could use. And so once you are in this platform engineering world and you need to kind of write the code to plug into one of these softwares or a software or a cloud provider, like your scope also becomes massive. So I think this is definitely not an easy role to be in, and you need to be like very high skilled to become a platform engineer. Not that you cannot have a junior platform engineer, but you still need a lot of senior people in that role to kind of see what is in this world, because the, once you think containers make it easy, but there's actually a lot of complexity to make this all work. Uh,
Hmm. Yeah.
And that's what a lot of people maybe also tend to forget, that there is actually a lot of complexity within the container world. Yeah.
Yeah, luckily those things got like abstracted away by the tooling. But yeah, obviously you see also with Docker, for example, they made such a big movement in the like container space in general. They pushed the container agenda, and it went so fast actually, and they had so much market cap, but they failed to monetize on it, I think. Just a bit like HashiCorp, I guess. Like they at some point they were like, oh, we also have to make money here. We can't just make tooling. Okay, let's change the licenses then. In that case, so we get some money, and then people are a bit upset. But also, yeah, by the end of the day, it's also how we pay our house, electricity, whatever. But yeah, but that's a different story for a different podcast, I
Yeah, we can
guess.
we can talk about this for an hour as well. Like
Because also
how
the cutoff for the licensing, we've talked about it yesterday on Slack as well. Like it was still quite realistic, right? Like it's not like the Java has done it similarly a couple of years ago as well, that every TV set-top box and whatever had to be licensed because it uses Java and whatever. But that's a different story. Let's dig into that in a different podcast. But no, it's super interesting. Like the space. Like if you could be a platform engineer, I think it would be an exciting role though.
yeah.
Because there's so much to still develop to engineer. Like I think it's more like an actual engineering role.
Yeah, it's also like it's super complex, the
Exactly.
containers, the APIs to talk to Kubernetes, talk to AWS. Um,
Yeah, for
but
sure.
your goal is actually to make it easier for the developer. So your goal is to take all this complexity and but make it super simple for the developers to do something on your
Yeah,
infrastructure, like run a service or spin up something. And yeah, like we said earlier, now with AI, like running all these models, you definitely need some kind of platform for that. And just tying yourself into let's say AWS, um, just using the products of AWS, like if you have a developer and you just only use SageMaker, for example, well, if you're gonna run your model just using SageMaker, it's gonna cost a lot of money.
yeah,
So there, because the underlying infrastructure costs so much money, it kind of makes sense much earlier, I think, to start platform engineering than when you just have to run an application. Like we said, okay, running applications is not very difficult. You
yeah.
just use something something to run containers on any cloud provider. Boom, you have a container. That's your compute. That's not too much difficulty there. But in the next years, I think we will need a lot of platform engineers, unless there's some really like an AWS just for AI that comes out or something.
Yeah, yeah,
That could also be. But if that doesn't happen, then I think you would need platform engineers just to make the cost of training and inferencing manageable
yeah, yeah,
uh,
yeah.
for
Oh.
all these AI models.
Yeah, that's an interesting approach because obviously, like all the providers make it easy to experiment with the technology and then hope you build a product on it, and then your
And
bill goes
credits.
up, up and up and up. And credits, yeah, yeah, like here is 250K in credits. Just do whatever you want, and then after that year, like year plus one, the bill hits, and it's like, oh, this is very expensive. Um, but obviously, yeah, like it did, you already have to have a significant bill to in order to justify the role. I think as well, like let's say you have, I don't know, 15K bill on SageMaker, for example. If you were to build your own platform to offset that cost, like you know what I mean, right? It has to be worth the money. So there's a sweet spot.
Yeah, but running an application is not going to cost you 15K per month.
No, 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 definitely not. No,
But generative AI,
that's what I was hinting at.
generative AI indeed is like, well, once you need GPUs, it's going to cost you a lot of money.
Yeah,
And
exactly.
so that's what I mean, that you're going to be much quicker there than with just needing some
Yeah.
compute.
Exactly, exactly. Like, yeah, makes total sense. Makes total sense. Yeah, but interesting space. Obviously, in episode triple digits, we will obviously talk about it again about uh, how the future looked, and to see if our predictions came true. But it's
Yeah,
yeah, it's
I actually hope that there will be some kind of new innovative cloud provider that is not Amazon, not Google, not Microsoft, and it
the
will say,
rises.
well, I have the cheapest GPUs and I have the API and I have everything that you need
Yeah,
here. Just implement my API, like use my interface to run your models, and somehow just because they are so much cheaper, everyone is like, yeah, this is the one that we have to use,
yeah,
and then the other cloud providers will have to react, because now you remember when we started with AWS, the price always
yeah,
went down.
yeah,
Like, oh, there's a new instance type. Oh, now this new instance type is so much cheaper. So everyone is like, oh, let's jump on that instance type.
yeah.
That already didn't happen for like years now.
Yeah, the
Like,
graviton, for example, yeah, that's quite some time now already. Yeah.
storage became cheaper, compute became cheaper, cloud prices stay the same.
But it's also because it's commodity. If you see compute, how many compute providers can you like even not only the big three cloud providers, but also like the smaller ones started to do like every small web hoster also is offering Kubernetes, for example, stuff like that. So I guess also they have to kind of compete with that. Obviously, this more feature rich in the big cloud providers. But yeah, it is also like, especially with like you, it's an interesting topic as well. Like the GPUs, will have to be, I think, also not only someone who can do it cheaper, but who can also design their own hardware. Because like I think like the big hard like Nvidia and that builds the actual GPUs, their order book is so full with the biggest cloud providers. They're not gonna like say, "Oh, you're a startup to challenge those markets. Let me sell this to you cheaper." You know what I mean? Like,
Yeah, it could be also an inferencing instance that is not based on NVIDIA, but
yeah,
then
exactly.
all the tooling is based on these NVIDIA
Yeah,
GPUs. So there's still a lot of things that need to
platform
happen before
engineering.
you.
Yeah,
Yeah,
exactly.
not even, but yeah, you first
The
have to change the Python
yeah,
libraries
yeah,
and the
exactly.
underlying kernels, because they use NVIDIA to accelerate everything.
Yeah,
They would have to use something else. And then you could be able to use another cloud provider that actually has some other inferencing chips, for example. Yeah.
yeah, definitely. Because I don't think like Nvidia will be like, "Oh, let's sell it for cheap to you," and then upset the other three biggest of my clients. So yeah, it's going to be an interesting space, obviously.
We will also see, but indeed, I think platform engineering might be even more becoming more popular as well.
Yeah.
Also, going back to this reducing cognitive load, if you see how much more complex all these how much complex everything is becoming, if you look back, you would deploy something in 2014. Well, you kind of build an image, a VM, put the app on, it can auto scale. There's no abstractions within this
No.
one VM. But now you have, I mean, I don't even know where to start anymore because there's so many abstractions, right? It's uh, where do you even start? Okay, there's still the VM, but within the VM, your network is abstracted like multiple times. There is NAT involved because, okay, you have multiple pods in Kubernetes example running on there.
Yeah.
Um, there's so many more abstraction layers, so many things that can go wrong that maybe platform engineering could also be like, there's too many abstractions. We actually just want to run something simple. Um, could be anything, right? Could even be AI models. We just want to run simple without all these abstractions. I'm just going to build again.
Yeah.
I'm gonna write a tool that's just going to build a virtual machine and launch it somewhere. And this is going to be it, back to where we were.
Yeah, exactly. But if you look at, for example, Terraform is a good example as well. I think, like, if you look at Terraform in the beginning, it was like we have a descriptive language. You just declare what you want to run, you run it, and you have the it translated to resources on a cloud provider. And then they added some functions here and there, and all like to make it easier, obviously. But now, if you can see what complex actions that you can do in a tool that I think was not not. I hope I don't hurt anybody's feelings here, but you know what I mean. Like, I don't think it's
That's not
it's
designed
it's
to
not
do that.
designed to do that. It's just a
You're going
declaration
from a
of resources
decla
instead.
Yeah, from a declarative model where you just describe something into, wait, but here in this line after the equals, you can actually put a loop and another loop,
Yeah,
and then
exactly.
refer to another variable, and then, or maybe another function in your provider or in Terraform. Yeah, it
Yeah,
becomes
it
super
seems like
complex.
so unnecessarily complex. And then, yeah, obviously, if you come across infrastructure like that and you do like Terraform plan, resource changed. Why? Ah, yeah, because the loop in that and the variable over there, and then it becomes like a debugging hunt, like with a full flat like programming language instead of like just plain Terraform. And yeah, like everything becomes like an abstraction of an abstraction of an abstraction, while it was initially designed to be reduce and the complexity and the cognitive load into like, okay, this is now full featured programming language almost, for example, but like by
Yeah,
figure of speech. But
and indeed, maybe when you are at the point with a tool like Terraform and it gets so complex and the code is unmaintainable because you need to do so much advanced things that is maybe indeed better to than instead of trying to write a programming language within this what used to be a declarative language to
mhm.
then indeed switch to really just like writing something in Python or writing something in Golang.
Yeah.
But then the answer is CDK. But I don't find that the answer. I don't find that the answer because CDK allows you to then write the code, but then still gets translated.
Yeah,
If
exactly.
there's Terraform CDK, so it gets translated back into Terraform, or it gets translated back into CloudFormation. And if then something goes wrong in this other abstraction, like within the code that is generated, or yeah,
You start
it
hacking
just gets
away.
as is yeah, it can get so complicated, and that's what I mean with what is the abstraction even? How deep are you? So maybe we don't need all this for simple applications or a
Yeah,
simple database. And a lot of these things you can trace back to Google because Google was actually with Borg.
yeah,
They were like, this is how we want to design our data center. And then Netflix with Spinnaker. Um, and these are all very complex organizations. But maybe for your organization, if you are a very simple organization, maybe you don't need all these things. And maybe you don't need all these technologies. So if they are abstracted away for you, fine, you don't see them. If it's managed, you don't see
leave
it.
them there.
Okay, I agree that we can use. But then when you are exposed to them for
Yeah.
example, with Kubernetes, then if something goes wrong, you are on the hook, you know.
Hmm.
And then that's what I'm saying earlier. Maybe we in so many years we will go back to like actually we went maybe too far, and then if I just deploy my application without any of these abstractions, any of these things, then maybe it will work. Because even then, when I was looking to back to what I said about these networking in this
Container D.
container D, you know that there's a big effort to do networking without root, without the administrator user.
Yeah, yeah.
So there is actually another layer that I added recently. That means that why don't we run container D as non-root? So then you have like network namespaces in Linux, and then you have like if you list like you log in as root and you list
Yeah.
devices, you see like I have one device. But actually now you have multiple namespaces. So you need to go into a namespace of a user, and there might be some more devices because that's kind of another deeper abstraction into a namespace. So,
Yeah,
you
yeah,
know, yeah. And then that's what I think. Then I think back to remember we once were at the Docker meetup in 2015, and some of these sysadmins were saying, "I'm not gonna run Docker because it runs at root."
yeah, yeah, exactly. Yeah.
Yeah, and then like, but it's irrelevant because you just own the VM anyway. So I mean, it doesn't make that much sense. And now I then see like, oh, but we can actually not run Docker as root because it's better to run it in the user. So we have more abstractions, and we go deeper. And then I'm like, who who can still see, what we are doing, it becomes all so complex, or maybe you should just go at some point back to let's just do something simple.
Let's start from scratch again. Like,
Yeah, also
like,
because if you look like if you look at software, right, you can actually, if you just say my Docker container is my artifact, you can have like a very clean Docker container with almost nothing in it. And
yeah,
if you use something like Go, you could just put your Go binary on it, and there's almost nothing. And if the rest for you is managed, okay, then you have complexity and whatever. But if the rest is managed by a cloud provider, but then on-prem you would still have the issue, right? On-prem you would still have all these abstractions, all these layers that kind of you are on the hook for. But if you would have like an easy way to maybe deploy container, but yeah, it's just that Kubernetes got so complicated, I think.
yeah, for sure.
Everything.
Yeah, absolutely.
And
Look at
then
all the
and
components it uses. Like,
yeah, and then this all comes back to the like this cognitive load, learning Kubernetes, super big effort, learning cloud provider, super big effort. Yeah, if you can put some platform engineering them in between, like a tool, some internal tooling, it just makes it easy again, for developers. Developers shouldn't be exposed to Kubernetes, shouldn't be exposed to all the difficult
yeah.
tooling on AWS.
And it doesn't mean that you can't be interested in how it operates and want to learn how it works. But like, if you look at, there's a GitHub repo, like setting up Kubernetes the hard way, for example, that's all being abstracted away by a cloud provider or somebody who runs it out to you. But if you look at it and set it up yourself, like how many components are involved, you see that it's been was designed by a very big organization. Same thing goes with Spinnaker. Like if you look under the hood, obviously you get the POC up and running in a container quite easily, but then if you start looking into maintaining it and all the specific nitty gritty details of all the, like, it's just a deployment tool, and that takes not just a deployment, it's like it's beautifully designed and stuff like that, but it's designed by a huge team, like a huge platform engineering team. And it's not like somebody who does it on the side, like you can run a Jenkins, for example. Oh yeah, the Jenkins server is there, and like, which also can be complex sometimes if it breaks down. But like, if you look at the complexity of Spinnaker, for example, like, yeah, that's interesting.
Mhm.
No, awesome.
Yeah, so I think what we are trying to say is just like we are in this space, we see so much complexity, and sometimes we are just wondering, can it be done maybe easier in the in the long term,
Yeah.
because uh like you just want to do something simple. And then maybe the last thing I'm going to say is like people that are not very technical and they want to just deploy an application, the first thing they ask me like, why is it so complex? Why can it not be easy?
Yeah, yeah,
Like, yeah,
absolutely.
well, this happens, kind of.
The majority of our meetings, at least let me speak for myself, but like when people are showcasing their architecture and then are like stuck somewhere and you try to guide them, is always like, just reduce complexity. It's always the same thing. Like even it depend not like technology agnostic, even like people try to overcomplify, but it's also because there are no boundaries, right? Like you can do
Yeah. Yeah.
run a container 25 ways, for example. So maybe I should do it this way because I have XYZ. While if there was only one way, we just choose that one and that would be it. Not that it's bad that there are options, but sometimes it's hard to see like the trees in the forest, if that is literally translated or if that's even a saying. But you know what I mean, right? Like,
Yeah.
no, awesome. Um,
So what are we? What
sorry.
are we for? I think we are most focused on cloud, like in within those three
Yeah,
titles.
yeah. But there are
I think
still
we are most.
synergies between those things that we have to step out the boundary and go more to that side or to that
We
side.
we we, we did
It's
some
like,
we did some platform engineering, definitely. Like where it was at gaps, we also did some platform engineering
yeah,
for some of our customers that need something,
yeah,
some certain
exactly.
features, certain simplicity, certain abstractions. Yeah.
That makes total sense. Make total sense. Was a pleasure again talking to you about this topic. I see we are already almost an hour in already again.
Yes.
So that's good.
Yeah.
So we didn't even like overshoot the majority of the podcast creators, but also it's a long episode again, which is also good.
Yeah.
Awesome. Edward, thanks for your time. And yeah, next week we'll launch another episode. We'll see what
Yeah.
topics we are going to discuss, but it's probably going to be
Indeed.
aligned in
Yeah.
all right. Take care. See you soon.
Yeah. Bye
Bye
bye.
bye.